Good evening, everyone. Welcome back. There was a technical problem, so I couldn't continue with the class. Like now, we will continue. I'm extremely sorry for this technical issue. So suddenly, I don't know suddenly what happened, but something happened. I'm not that techy. Yeah. Okay, so we were discussing about the possibilities of numericals in refraction of light on plane surfaces, right? So here are few possibilities. Like in refraction of light, you can expect the numericals, or you can expect maximum number of the questions from the Snell's law, and thereby the relation between refractive index, velocity of light in different medium, and then refractive index and critical angle relationship. Okay, that is different and this is different, right? So in this way, good evening, Prakash. In this way, we can just relate all this. I hope you all are able to hear me clearly, because the previous session somebody has complained that the volume was not clear. Okay, so I hope you all are able to hear me clearly, and you all are able to see what I'm able to write on the screen. Okay, if any certain problem is there, you just let me know. Right. So as we were discussing, and now I'm not going deep into the how refraction pattern takes place and all that. I think you all know refraction is nothing but a simple definition of refraction of light as bending of light in different medium, isn't it, right? So before we go for that, I think you all know, like, there are two types of medium which actually exist. What is that? One is optically denser, and next one is optically rarer. What is optically denser medium? Optically denser medium is one in which velocity of light is less. Optically rarer medium is one in which velocity of light is greater. So whenever a light ray travels from one medium to another medium, for suppose the light ray is traveling from air to water, it is entering into water. So there exists a the change in the velocity of light, isn't it? Obviously, because of the change in the velocity of light, it results to bending of light rays. Means light ray actually, according to the rectilinear propagation of light, it should travel straight. But as there is difference in the or as there is difference in the velocity of light in both the medium, the light ray either bends towards the normal, or the light ray goes away from the normal. This is how the light ray behaves when there is change in the medium. And the behavior of light ray is completely depending upon the velocity of that particular medium only, right? I think you are aware of all these. Like whenever a light ray travels from denser to rarer, whenever a light ray travels from denser to rarer, it bends towards the normal. When light travels from rarer to denser, it goes away from the normal. And whenever a light ray travels from the normal, what happens? Light ray is falling onto the surface from the normal, like this. Right. So when it is going from the normal, it goes without any particular deviation. It goes without deviation, right? But when it is going from the denser, rarer to denser medium, it bends towards the normal. When it is going from denser to rarer, it goes away from the normal. So in the first case, when it goes from rarer to denser, the angle of incidence is greater than the angle of refraction as it bends towards the normal. And when it is going from rarer to denser medium, the angle of refraction is greater than the angle of incidence, right? So what happens? Like now we have come to know that there will be some bending of the normal. So can you please tell me where you will see such a diffraction of light? Means what are the consequences of bending of light ray? What are the consequences? I hope these particular things you have learned in your smaller classes, like take water. I mean, take some amount of water in the light. When some amount of water in the beaker, and then the light ray completely, what do you say, bends towards the normal anyways when it is going from the rarer to denser medium, right? Now for this, what you have to do is you need to take some what the paper, and then not paper exactly, you can take a long stick, and then half of the stick you put inside the water and half outside the water. What do you observe? Like if you seeing the stick straight, what do you observe here? You will observe that the part which is inside the water just goes away from the normal, and it sees that they are not straight. Means when your half will be inside the water and half will be outside the water, so you see that the stick is not straight because of refraction. Like inside water the light rays are bending towards the normal, and outside the water it is actually incident rays, right? So that is the reason why you see all these, this is how this is one of the consequences of refraction of light on the on plane surfaces. Apart from that, you can take a coin and place it in a beaker. Now fill the beaker with some amount of water, right? A certain amount of water you are filling it, the beaker, and then start seeing the coin which is inside the water. What do you observe? The beaker, the coin seems to be very near than its actual length or than its actual height, because again this is also because of refraction only. Not only that, even I think you might have observed the fish inside the water, isn't it? Usually when you see the fish inside the water, the fish seems to be bigger in size, and the fish seems to be nearer. But actually, when you take out the fish from the water in the aquarium or something like that, when you take out the fish from the water outside, then what do you observe? The size of the fish seems to be smaller than the size of the fish which you have seen inside the water, right? So what are all the what why all this is happening? This is only because of refraction, okay? But if it is refraction, all these should happen. Yes, all these should happen. Why? Because there is a very important the reason for this, that is velocity of light. Because of the change in the velocity of light in the different medium, this particular things, these all of the things are happening because light is not traveling straight when they are changing the medium, okay? So this is how the light ray takes place, the refraction of light ray takes place when these are all the consequences of refraction of light which we see in our our day-to-day life, right? Even twinkling of stars also is a result of refraction of light only. And yeah, all these are happening because of refraction of light, and these all are actually irregularities, we can say. What irregularities? Light is not moving straight. This is a very important irregularity what we observe during the refraction of light, right? So because of all these irregularities, these are the consequences, these are the results what we are seeing in our day-to-day life. Okay, so this is about the refraction of light and on plane surfaces. And to learn more, we have to learn the laws of refraction. Okay, there are two laws of refraction. I don't think this is working. Laws of refraction. According to first law of refraction, the incident ray, refracted ray, and the normal all lies on the same plane. That way you know, right? Coming to the second law, which is very important. According to second law, sine of the angle of incidence is directly proportional to sine of the angle of refraction. Meaning, as long as I value increases, as long as incident angle increases, then refraction angle also increases. Sine of the angle of incidence is directly proportional to the sine of the angle of refraction. Then if you take out the proportionality, you get a constant which is represented by mu. Mu into sine r, right? That is mu is equals to sine I by sine r. Mu is equals to sine I by sine r, which is nothing but the Snell's law. Okay, so what is mu here? Mu is called as refractive index. What does this refractive index is? Refractive index is different for different medium. Okay, usually for denser medium, refractive index is greater, and for rarer medium, refractive index is lesser. That is, mu is inversely proportional to velocity. Meaning, in wherever velocity is greater, that is in denser medium, velocity is greater. The velocity of light, in denser medium, refractive index is greater. That means velocity of light will be lesser. And in rarer medium, velocity is uh, greater and refractive index will be lesser. Okay, so it is like vice versa. Mu is inversely proportional to V. Now, we will relate refractive index, velocity of light, and sine of the angle of incidence and diffraction by taking a simple formula when light ray is traveling from the rarer medium to denser medium. Okay, so what happens when the light ray travels rarer medium to denser medium, and how can you connect all these physical quantities which you have learned just now? Okay, refractive index plays a very important role, and I can say that that is the ability of a medium to allow the light rays to pass through. Meaning, like every medium can't allow the light ray to pass through. Like, you know, there are certain medium, like for example, if you take wood, okay, wood is a particular substance which will not allow the light rays to pass through. So naturally, its refractive index will be completely different, right? So whereas if you take water, water is transparent, glass is transparent, all these will allow the light rays to pass through very easily. So basing on that, refractive index also changes, right? So in this way, refractive index plays a major role in refraction of light. Now, whenever a light ray traveling from rarer to denser medium, as we have learned, it bends towards the normal. So what happens to how do you relate all these? Let us see. So the comparison of refractive index of second medium to first medium is equals to velocity of first medium to second medium, because it is inversely proportional, is equals to sin I by sin r. Now what happens here is light ray is traveling from air to glass, for example. Okay, that is redder medium to denser medium. If it is traveling from air to glass, I can write mu2 by mu1 is equals to this velocity v1 becomes velocity of light in vacuum, this is c, by v in the medium is equals to sin I by sin r. Okay, now what is c here? C is nothing but velocity of light, which is equals to, what is the value of c? Can anyone tell me? Value of c is 3 into 10 power 8 meter per second. I think you all know this, right? Can you tell me what is velocity of light in the medium formula? Can anyone tell me who are online? No one? What is the formula for velocity in a medium, particularly velocity formula? Can anyone tell me? Velocity formula? I don't know how many of you are online, but I could see someone is watching. Can anyone tell me? Give me the hint. Fast, fast. Prakash, are you there? Who else are there? So we have velocity is equals to, there are two formulas actually. When you take frequency into consideration, then velocity can be written as frequency into wavelength. You know this? And velocity can also be written as distance by time. So in this velocity of medium, yes Prakash, yes, distance by time. Yeah. In this velocity of light in the particular medium, if you can see, you can replace that particular v with these formulas and find out the unknown value. Like for example, in a problem, in a numerical, if they give if they give velocity, refractive index of first medium to second medium, Prakash, U plus 80, we usually don't use it. In light, we don't use it. Okay, that is actually, we are just trying to finding out the velocity of light. No, isn't it, Prakash? Right? Yeah, it's okay. So so here we use all these. Means we can replace velocity of light medium in by using frequency into lambda, or by using distance by time also. Whereas c a value will be always same, that is 3 into 10 power 8 meter per second only. Okay, so this is how you can relate refractive index, velocity, and also sine of the angle of incidence to sine of the angle of diffraction. So, but this particular Snell's law can be applied in many different cases. In finding out the critical angle, we use this. In finding out the total internal reflection, also we use this. And anyways, we will move forward to that. But before that, here we have got something. I asked everyone to download. As I told you earlier, this session is you are viewing from the Spark Academy YouTube channel. So if you want to subscribe to any of the Spark Academy activities or crash courses, just download. Go to the Play Store, type Spark Academy, download the app, and then you get greater discounts. You can use my particular code also ANU10 to get the discounts with my coupon code. Okay. Now in the app, what you will have? What is the advantage of downloading this particular mm, app? Okay, you will have 110 notes. You will have free study materials, and you will have previous year questions, question papers, solved question papers will be there, and the free mock tests. Yeah, the Spark Academy gives long-term courses, crash courses, mock tests, previous year solutions. Previous year question paper solutions will be there, full length tests, and the study materials obviously will be given when you click on the link in the description. Then you will get different courses which are offered by Spark Academy, and you can choose any of your interesting course and join here. And we have short term coaching, regular coaching, and then crash course we have already started. Okay. Short term coaching from 10 to 4, and regular coaching from 6 to 9. And then, yeah, we have offline and online coaching. Offline classroom coaching, offline classes, Naranguda and Mehdipatnam we have. Okay. Yeah, online coaching, we have live course, NEET 2020 online coaching, JEE Mains 2022 online coaching, EAMCET to 2022 online coaching. As I told you, you can use my coupon code ANU_10, and then you will get the discounts there. And every day, even if you miss the class, the advantage of Spark Academy is, even if you miss the class also, you can go to the store, the app. All live recorded sessions will be there. You can attend the class anytime there. Okay. Yeah. So we have assignments. Everyday assignments will be given in the Spark Academy app. Will be posted, and tests will be there. And then you can see how after the test the analysis will be like this. Our methodology, basic concepts, shortcut methods, all model questions, exercise questions, PYQs, chapter-wise tests, weekend test, grand test, and test analysis. Okay. Why only Spark Academy means we have highly experienced faculty and personalized coaching, process oriented coaching, personal mentoring and doubt clarification, and limited batch size. That is the advantage of Spark Academy. Okay, now we have access to classroom. When you compare that offline and online, we have access to classroom in online, offline, and obviously online no classroom session, it's only online. And then excuse me, books. Books will be available for classroom coaching. Online coaching, we will send the study material online. Okay. And weekly tests will be conducted for both online and offline. Grand tests will be there for both online and offline. And doubt clarification in person will be there for offline. When it comes to online, Online, it is only online coaching. Okay, the doubt clarification will be made only online. Okay, so this is about the Spark Academy. Now, as I told you, we were discussing about the relation between refractive index and velocity and sine of the angle of incidence to sine of the angle of refraction, right? Now coming to the critical angle. Whenever light ray travels from the denser medium to rarer medium, we know that it goes away from the normal, right? So, according to Snells law, the concept of Snells law now we will apply here. What did you learn? Sine of the angle of incidence is directly proportional to sine of the angle of refraction. For example, if you are increasing angle of incidence, go on increasing angle of incidence, angle of refraction also increases, right? And increases in such a way that at one point it just grazes through the surface, right? So that means you are increasing angle of incidence and at one point it is grazing through the surface. Okay. When it grazes to the surface, angle of refraction is equals to 90 degrees. Means at one point you see that the angle of refraction is 90 degrees. So when the angle of refraction is 90 degrees, whatever value of angle of incidence is there, that is called as critical angle. So for 90-degree angle of refraction, angle of incidence is called as critical angle. Okay. Now we will apply this in Snell's law and try to find out the relation between the refractive index and the critical angle. So as this is, usually what you will write Snell's law, mu 2 by mu 1 is equals to sin I by sin r, right? But here what is happening? The light ray is traveling from denser to rarer medium, not from rarer to denser. It is in the reverse case. So in such reverse cases, the Snell's law can be written as mu 1 by mu 2 is equals to sin r by sin I. What is sin r? Sin r is 90 by what is sin I? Sin I is sin c. Sin 90 is 1. So this will be mu 1 is refractive index in the medium. Mu 2 is refractive index of air which is equals to 1. Okay. Mu 2 is second medium. Here second medium is air. I hope you understood. So this will be mu is equals to 1 by sin c. This is the relation between refractive index and the critical angle. Now what happens if you are going on increasing the angle of incidence? Going on increasing, in the previous case if you can see, already the light ray has grazed through the surface, means the light ray has come here. And angle I is equals to angle C, that saturation point it has already reached. Now if you are increasing angle of incidence more than the critical angle, okay, you are increasing angle of incidence more than the critical angle, then angle of refraction means already light ray has come here. Now light ray, instead of going like this, it goes down. Okay, it goes down, means instead of refraction, now this is reflecting. Okay, so this is reflecting. This particular reflection is called as total internal reflection. Okay, total internal reflection. Total internal reflection happens in two cases. The first thing is light ray should travel from the denser medium to rarer medium, and light ray should be, angle of incidence should be greater than the critical angle. In these two cases, the total internal reflection occurs. Right? These are the conditions for total internal reflection. Total internal reflection plays a major role in the science of, light. Wherever you see light, it is applied, it is seen, or mirages are due to total internal reflection. I can say it is seen in the twinkling of stars, and it is seen in the rainbow, formation of rainbow, and it is seen in fiber optic technology also. Total internal reflection is seen, and total internal reflection is also seen in medical diagnostic and all that. For endoscopy things and all, we use total internal reflection only. Okay, so and also brilliance in the diamond is also due to total internal reflection only. So all these, total internal reflection results, all these which we usually observe in our day-to-day life, right? So this is, as I told you, there are the two important conditions for total internal reflection to occur. That is, first thing is light ray should travel from the denser to rarer medium, and second thing is angle of incidence should be greater than angle of refraction, right? So this is about the total internal reflection and applications of total internal reflection. Okay, right. So we have few numericals which are related to the topics which we have discussed today. The numerical part we will discuss in our next session. How to relate and all that we will discuss in our next session. Before we end up this class, I again tell you, we this particular video session, live session, you are seeing through the Spark Academy app. Spark Academy YouTube channel. We have even the Telegram group also. Lot of discussion, lot of things will happen there. You can just join our discussion session in the Telegram group. Okay, so this is about the Spark Academy, today's Spark Academy refraction through the prism, the refraction of light through the plane surfaces, right? Thank you for joining this class. I hope this class is useful in some way or the other to you. And numerical part we will just start doing tomorrow. Next class we will just discuss the important numericals which have come in the last year EAMCET, JEE Mains and NEET. We will discuss all this from the topics what we have discussed today, right? Until then, bye, take care. This is Anupama signing off from the Spark Academy. Thank you so much for joining.